line is coming here. Similarly, you click here. So that means your line is, that means you are just clicking at these points. This is one point, this is point. So all these points you are clicking. So basically you are adding lines when you are clicking. That is called a point mode of digitization. Other mode is, suppose I don't want to do this, what I do is I can do a stream mode of digitization. Another is, this is called a stream mode of digitization. Here what you are doing is, I put my pen there or a digitizing mouse, then I start continuously moving. So if I know how to move, so probably I am an expert, so then I can draw my line exactly onto this line. So this sometimes may be the faster also, and then easy also. So this is called a stream mode. What I do here is, I did a continuous stream mode or a point clicking mode. So both the options you can use. Another important point is, when you digitize, you can also give a tolerance, like a tunnel tolerance. It is something like that. You specify this the distance in which I should move. That means I should be moving my mouse like this continuously. So suddenly there is a spike coming like this. So that means you did a mistake. You should follow like this. So then if you specify the tunnel tolerance, whatever points are going, so it may not be digitized. So then your error will not be there. So that is called a tunnel tolerance. So then you see, if you specify tunnel tolerance, if you created so many points which the GIS has to store, and then those points maybe I don't require. So if you specify that within that tunnel, if there are many points are created, those points can be removed. Those points, what I can do is I can remove those points and then add only nodes wherever is required. So that you are removing the additional nodes which are created in this stream mode of digitization. So that's what, this is a detected points and recorded line. So this is the final recorded line. So this is the points and lines which are created, which are not required to be there, which can be removed. That means smoothing those lines. So far we discussed about digitizing, we discussed about a manual digitization, and then we also discussed about what are the errors we notice while digitizing and how to remove those errors. So then we'll discuss further those things, but let us also now discuss about the scanning. Scanning is important. What I said is, when you scan also your map, when you scan, you should know that at what resolution I should scan. So it is scanning means process of obtaining map into a computer using a charge coupled device, CCD based device called a scanner. The scanned map is in the form of image or a raster format. You can say JPEG or TIFF image. You have to digitize the image or raster in order to get a correct vector map. Okay. So these are the different type of scanners. Suppose you say this is a smallest scanner, A4 size scanner. So where you normally use for the document scanning, but this may not be useful for GIS. But there is a scanner like a bigger scanner, it is A3 size scanner, and then these two are a flatbed scanners. If you categorize the scanners into different things, you say flatbed scanners, and this is a large format scanner. This is a large format scanner where your charge coupled devices and light source is embedded here. Here your map is moving, and then your equipment or sensors are stationary. In this case, your map is fixed, and then your sensor and light is moving in this. So if you see that in this, see, this is another type of scanner. It's called a drum type scanner. You have a scanner like drum type. You paste your or fix your map onto the drum, and then drum rotates, and then you scan. In the case of flatbed, the light source is moving here, and then in case of drum type scanner, so on the drum your light source is focused, and then it is recorded in a red, green, blue channels, and then later on it is converted into a computer. So this is a optical splicing, converting into a 3 RGB channels. This is a drum which is rotating. See, you may be having a two different type of material to scan. One is opaque type of material. So that is like your paper map or topographical maps. So in that case, you have a light source at one side. Same side, you also have a sensor. So both the things are there. Then you will be scanning. And then other type is where you have a film. See, earlier days we used to get a film from NRSA. So like color film, color satellite data, so that is to be coming in a film. So in case of film you are using, so your light source is other side, your sensor is other side. So then you do the scanning. So that way it works. So then to give you more detail, so this is like a flat bed. On that you are putting your original map, and then you have your lamp. Lamp is basically moving. So it moves from left to right or right to left or like that. So when it moves, it is also focusing light on a original map. So original map you place it in a reverse so that your sensor can see from the inside. So then it is projected to a mirror, and then from mirror to it is projected to the lens. So lens to it is coming CCD, and then from CCD then it is going to your to computer like that. So then it is basically recording here. So once it goes there, then you record. So then when you scan your map, it is important. See, this is my map, and then the map is there on a white sheet. Okay, this is map. Basically you say you can think of a runway in an airport, which is the black colored, your road map, and other all thing is white. So you can think of any map, but this is a simple example. And then this map is having a certain size. I wanted to scan this map at the resolution of 0.05 mm. So that means it is, I am not scanning at 1 millimeter level. I am scanning at 0.05. So 0.5 means 1/28 of mm. That means there will be 20 these squares you can put in 1 mm. Okay. So you are putting your this resolution at 0.05 mm, and then when you scan, if it is a white area without any background, so then it gives certain value which is very high, 255,